Before you consider implementing any kind of optimizations on your database system, you should first consider exactly what your priorities are. An optimization for one factor in your database system may be detrimental to another factor. It's not always possible to please everyone all of the time. For instance, we may have such competing objectives as speed, storage space, data integrity, and security. Which of these elements you give priority to depends on the particular application for which your database system is designed. For instance, security is irrelevant if you are running a simple database system for yourself and it's only going to run on your machine and you never log on to the internet. However, for a critical high access database system running over the web, security is going to be a big issue. This will also increase with the higher the sensitivity of the data you're storing within your database system. Storage space is not necessarily a particularly high priority, at least not as much as it used to be some decades ago when storage space on hard disks cost a lot of money. Nowadays, storage space is probably the first of the priorities to give way when an optimization needs to be made and one of these elements needs to be sacrificed. Data integrity is very important. We've just looked at the normalization measures to ensure the integrity of data in the last movie, and speed is always an important factor. How important each of these factors is to your particular database is something that has to be worked out on a project-to-project basis. Here, though, are some general tips for optimization within your database system. To begin with, avoiding redundancy and duplication within your database design. We've looked at some ways to do that in the last movie with the normal forms. You should also, wherever possible, avoid variable length columns, such as varchar and text. This is one of the occasions on which storage space, as a consideration, should give way to the speed of access. If you include any variable length columns within a table, the way that it has to be accessed is a lot slower than if the columns are all fixed width. For instance, if you have a varchar column, although it will actually take up less physical hard disk storage space than a fixed width char column where you specify the exact width of the column, the char column will be able to be accessed much quicker. Of course, if there are any variable length columns within a table, such as if you have to store some comments or any variable length piece of data that is an important integral part of that table, then you may as well make the other columns within that variable length as well, because it won't make any difference whether these are fixed length or not. In this case, it's one bad apple spoils the bunch. Sometimes it's very useful and important to use variable length columns. At all other times, try to avoid them and use the fixed width columns such as char and so on. When you are designing your tables, use the smallest possible column types. Don't use an int column type where you can use a tiny int or a small int. On the other hand, try to foresee all realistic scenarios when you create your database design. If it's possible that your number of clients will swell from 40 to 4,000, then make sure that your database can be easily scaled without any kind of database redesign. You therefore wouldn't want to use, for instance, a tinyInt as your ID column for your client table. Also use unsigned wherever possible. This increases efficiency in the storing of your data. From time to time, as you make delete statements and insert statements on the data in your tables, your data will become fragmented in the way it's stored on the disk. If you use the optimized table statement on your tables every now and then, you don't have to do it too often, but if you remember to do it every now and then you'll be able to make the reading of that data more efficient in the future. It works similarly to the defragmentation of your computer's hard disk. Similar kind of concept. We've talked about normalization and the benefits that it gives. Once you've learned the rules, they say, then you are at liberty to break them. You should always consider the possibility of denormalizing your tables in a very judicious manner to give certain performance boosts to your system. You may want to have some kind of duplication of data in certain circumstances in order to increase the speed by, for instance, cutting out a join between two tables that's needed when you're going to be accessing a large amount of data. This should be done with care, however. Consider the normal forms framework from which you should only break out if you have very good reason to, and you know exactly what the repercussions will be. However, denormalization is sometimes a way to increase the efficiency of your database system. Strange though it may seem. If you create any temporary tables within your workings of your database, for instance, if an application that accesses your database system needs for some reason to create a temporary table using MySQL, it should use the heap table type rather than the standard MyISAM table type. This allows the table to be stored in memory rather than being committed to hard disk. This is of course much quicker. If you use default data on every column wherever possible, then the speed of insert statements will be dramatically increased if you're using a lot of insert statements. So use default data wherever possible. And finally, possibly the single most effective way you can speed up your queries, apart from a good database design, as we've looked at before, is to use indexes on columns in order to speed up your queries. Let's take a look at this last one in the MySQL console. This is not something we can discuss in a vacuum. We'll go to our sample database and let's run a particular query. Now I'm going to make this query particularly involved and convoluted, just to give an example of a difficult query to work out exactly what it's going to do before you evaluated it. We're going to have 4 tables joined and we're going to join at 3 places. This will return a particular set of results. Basically what we're trying to find out here is who bought what when. So Simon bought the Pelican mask on the 10th of February, for instance, 2002, and so on. If we want to examine the efficiency of this query, there's a very useful MySQL command we can use to do so. Let's go back up to the select statement at the top there and add the command explain. What this will do is it will work out exactly how the query works and give us a little report. Rather than carrying out the query itself, it will report on the way it would be carried out if we did carry it out. So if we just use the keyword explain before any query, then we will get a certain set of results back as a kind of analysis of the efficiency of the query. Because of the small screen size I'm having to use here in order to create this particular video, the table that is produced by the explain command has been split into different pieces. However, you should be able to see the different headings: table, type, possible keys, key, key length, that is key length, and the reference, the rows, and any extras. As we can see, the possible keys column contains primary for the last 3, but null for the top one. And the null for the top one, actually, if we look over at the table on the left-hand side, if you could read that in the broken column there, it is quite difficult to read, I know, but there's an OI, and this OI refers to the order items table. Now, the order items table has no primary key. Has no key at all, in fact, because it's simply a linking table between the orders table and the products table. This is why the values for this table differ so strongly from the other values of the other tables, the results from the other tables. For instance, in the type, eq_ref is listed for the other 3 tables, whereas under the OI table we get the result all. This means that all rows have to be searched on the order items table. One way in which we could speed up this particular query is to add an index. All we need to do is use the alter table statement, then give the name of the table, and simply say add index, and we'll tell it which column or columns we wish to add an index to. Let's say we want to add an index to order ID and product ID. That's been done. Now if we repeat our explain statement, as we can see, the possible keys column now contains the order ID column rather than saying null. The key that's used is the order ID, key being a synonym for index, and the type is now listed as index for the order items table rather than null. Since we have so little data in all the tables, there is no actual performance difference that is viewable by running the queries. However, if we're working with a larger amount of data, then a table such as order items that has no primary keys or indexes is a prime target for optimization. Adding indexes to frequently used columns other than primary keys is a good way of speeding up frequently used queries.